along that way, and you can interact with me, you can ask me questions, and I can call your name and ask you questions too. And I'm sure we'll all be fine with that, okay? So after some minutes, I'll take us through some quizzes, which I will want every one of you to participate in, okay? Good. So just to get myself familiarized with you, okay, if you don't mind, just quickly tell me something, you know, about yourself, okay? If you don't mind, so I call your name, Oyewotoluwani. Oyewotoluwani. Yeah.
My name is Oyewotoluwani. I attend MGHS.
Okay, okay. Nice to meet you. Nice to meet you. Okay, I'm glad to meet you. Yeah. Usondo Matthew. Usondo Matthew. Usondo Matthew. Are you there? If you can hear me.
Good afternoon, sir. Yes, sir.
Yeah. Yeah, good afternoon. How are you?
Fine, thank you, sir.
Yeah, you sound so energetic. That's the spirit of chemistry. Yeah, welcome on board. Wow.
Thank you, sir.
Yeah, from which school, please?
Methodist Girls High School.
Oh, brilliant, 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 brilliant. I hope subsequent session you are going to tell your friends so that they can join, okay? Good. So
okay,
this is
sir.
just a demo episode, you know? Yeah, we need to work together, have a nice time. Good. Yeah, okay, so Mayo Kun, you want to tell us about yourself? Let the student experiencing chemistry get to know you. Mayo Kun, are you there?
Yes,
okay.
Sir.
Okay, so tell us just one thing about yourself quickly. Just one thing.
My name is Mayo Kun.
Okay.
I'm school.
Oh, brilliant, 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 brilliant. Okay, I've taken your work. Olatubosun, quickly, Olatubosun. Yeah, tell us about yourself. Just one thing about yourself.
My name is Olatubosun Dosin. I attend Methodist Girls High School.
Wow, wow, wow. I tell you, I'm going to get methodical this evening. Quickly. Yeah, if you're hearing me. Okay. In case you lost your audio, let me move on to someone else. Simisola, something about yourself.
My name is Simisola Olusola, and I'm from Holy Child College.
Okay, brilliant, 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 brilliant. Temisola, tell us about yourself. We've heard from Simisola, now Temisola. Tell us quickly about yourself.
Good evening, everybody. My name is Temisola Olajide, and I'm here attending Green Springs.
Temisola.
Yes?
Tell me about yourself quickly. Yes, say something about yourself. Yeah.
I play basketball.
Oh, brilliant, 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 brilliant. Okay. We have someone special here. She's the delectable, powerful chemistry tutor. She's also here to be with us. Miss Aneke. Oh, please, can we welcome her, please? Just say welcome to her.
Hi, guys.
Yeah. Okay.
Good evening, Mr. Victoria.
Yeah, good evening, energetic, beautiful Aneke. You're welcome on board. Okay.
Thank you.
Yeah, let's just kick start and move on. Okay. This is just a demo episode. Okay. We just take things a little bit easy. My focus will be to just explain in detail one or two concepts that cut across generally with everyone. They are like the foundation to chemistry, and see how we can correct one or two misconceptions. I can't wait to start. Okay, so the first thing I told you the objective of this section was just to get you, fall in love with chemistry. That's my focus. Okay, and of course we'll look at one or two simple concepts that we need to explain to one another. Okay, good. Now, I'm sure when you talk about chemistry, a few things come to mind. Okay, a few things come to your mind. Some people think about test tube. The moment they talk about chemistry, what comes to their mind is test tube. Okay. Who wants to tell us what comes to mind when you hear the word chemistry? What comes to mind when you hear the word chemistry? Anything that comes to mind? What comes to mind? Quickly, someone. Yeah, just speak randomly.
Calculations.
Calculations. Oh, some people dread calculations in chemistry, like, oh, I can't calculate all those moles, molar mass, relative atomic mass, and all that. Okay, what else comes to mind when you think about chemistry? You can talk, you can use the chat session. Yeah.
Anytime I think of chemistry, I usually think of experiments, such as citation experiments.
Yeah. Menoma writes, he says she thinks about experiment. That chemistry is all about experiment. Well, that's cool. That's fine. That's fine. That's fine. That's fine. Yeah. Okay. Really, chemistry. Everything you have said, fantastic. Fine. Okay, but looking at chemistry from those angles may limit your expectation. I mean, may dampen your enthusiasm in learning chemistry. Okay, if you can see my slide, you can see the universe there. I'm trying to represent the universe. Okay, now imagine you seeing the universe in your book. Okay, universe is so big in exploration. We have various colors, we have various diversity. If you look at chemistry from the point of view that chemistry is life, then you bring it more closer to you. Okay, everything you see in the universe is made up of matter. And of course, chemistry, we'll say, is the study of matter. How matter, have been arranged, their diversity to give rise to the various, things that we have in the world. We as humans, for example, we are a combination of different matters. And of course, if you want to break down matters deep down, you now begin to talk about the elemental form of matter. The book that you're writing on, if you have a book with you presently, is made up of carbon, oxygen, hydrogen. And this is what combined together to form the polysaccharide from which the pulp is being made. Okay, so chemistry basically is life. Now, if you look at life all around us, we have a whole lot of diversity. That diversity is as a result of the fact that we are all not made from the same element. We are made from different and diverse elements. Okay, so I want us to move from saying chemistry as life and you having a better appreciation to chemistry than just seeing chemistry as a test tube or something that has to do with calculation, something that has to do with experiment. Just see chemistry as life. Okay, so it is the basis of our existence, basically. Chemistry is the basis of our existence. It's about mixing matter together to give rise to different forms of existence of either human, living, and non-living things. Okay, so of course you are aware that chemists speak certain accent. As I'm speaking this way, you definitely will begin to know from which part of West Africa I came from. I know someone joined us from abroad, is presently in this class now joining. So if you're looking at this person talking, you definitely will be able to say, oh, this is not a British, this person is not speaking with British accent or American accent or Canadian accent. Yeah, I'm a core Nigerian and a Ibile Yoruba man. Okay, so you can feel my accent as I'm talking. Now, when a chemist speaks certain accents, certain language. There are one or two things that a chemist will say that when you hear that, you'll be able to say, oh, this person is a chemist. And I call those things the accent of what? The accent of chemistry. Okay, so now, when a chemist talks, there are certain accent that comes out. There are certain terms, okay, terminologies that chemists use. We'll talk in terms of atoms, we'll talk in terms of elements, we'll talk in terms of molecules, we'll talk in terms of compounds and ions, okay? So if you want to have a better understanding of chemistry, as simple as these terms are, The moment you mix up those terms, you begin to have issues with other topic in chemistry, with other aspect in chemistry. If you cannot differentiate between atoms and ions, you find it difficult to deal with topics like electrolysis. If you cannot differentiate between molecules or compounds and elements, you find it difficult to deal with topics like bonding. So every topic in chemistry has a foundation, okay? And so your knowledge and grasp of those foundation needs to be absolutely strong. Okay, good. So maybe we should come along and start from this, accent that chemists, speak. Okay, atoms. How do you think that elements differ? How do elements differ? Okay, so I'm sure you. Yeah, I want to watch the slide. I'll see how one or two elements differ from another in terms of their building. Now, looking at this, from the smallest elements that you have to from the smallest one, that is starting from hydrogen, and you move on gradually until you get to calcium in this particular example. What do you think differentiates those particular different atoms that you saw there? What differentiated them? What particular thing is being added to each atom and the atom begins to change? Who want to tell us? What do you think you saw there that was being added to each atom as the atom is being built? And of course, the type of element was being changed. Anybody? Who want to help us? Oyewol, Semisola, you want to help us with that? Okay. So, would someone tell us what he or she understands by the term atom? Okay, brilliant. Olatubosun Tosin, thank you for that response. She said increase in atomic number. Absolutely correct. Absolutely correct. If you look at the video, okay, as you are moving from one element to another, the type of atom was being changed because something was being added gradually. Something was being added gradually to the initial atom, and it was being changed to another atom. And that was because you have an increase in atomic number. So you can see that the diversity in the world that I spoke about initially started from a little nitty-gritty, just something small that is changed from atom A to atom B, give rise to a new, element. Okay. Of course, I was asking who will tell us what he or she understand by the word atom. Atom. What do you understand by the word atom? Apart from my own definition, atoms. Any other definition you know of atoms? Any other definition? We are looking at the terms that scientists use, chemists use in describing the things that they do. Oh, thank you, Oyewol. Oyewol said atom is the smallest indivisible particle in a chemical element. Smallest indivisible particle in a chemical element, okay? I'm pretty sure many of us have heard about that definition, right? Just one more definition. Somebody give us one more definition of an atom. One more definition of an atom. Then we'll try to clarify one or two things about the definition and we'll proceed and move on. Any other person? Olo Kumbose, you want to help us? Abisola, you want to help us? Usondu Matthew, you want to help us? Something about an atom.
Yes, I'm going to.
Yes, please.
I just wanted to add that the word atom comes from a Greek word for indivisible. So that might help.
Okay, good. So we'll look at those three definitions now. Okay. Temisola is adding to the fact that that word atom from the Greek word indivisible. Indivisible means it cannot be split into simpler substance, right? Okay, good. So in expression, in essence, you might want to see atom as indivisible, okay? But of course, you know, we have protons, neutrons, and electrons, right? Do you guys know that? We are aware, right? We have protons, neutrons, and electrons, and they are components of atoms. Okay, so if those are the components of atoms, then how come we say that an atom cannot be divided, cannot be split into simpler substance? So that tells us that the things that scientists do, okay, are progressive. Knowledge is progressive. So initially, in time past, they will say an atom is the smallest indivisible, okay, part of an element. You will be absolutely correct. But over the years, as advance in knowledge is being attained, we found out that an atom can be opened up, can be split into the various components that we just mentioned, the protons, the neutrons, and the electron. So it will no longer hold water to say that an atom cannot be divided. Okay, so therefore, it is better to say that an atom, okay, is the smallest part of an element yet, but that smallest part of an element retains its its chemical properties. So this is what we mean when we say the smallest part of an element that retains its chemical properties. If you look at this atom that I'm showing on the slide, okay, this is hydrogen atom, right? Okay, so if we divide hydrogen atom into its subatomic particles like electrons and protons, electron cannot retain the property of hydrogen. Proton cannot retain the properties of hydrogen. Okay, so the simplest thing that can retain the property of hydrogen in this case is hydrogen atom. So we therefore define an atom as the smallest part of an element that still retains its chemical properties. For example, I am a human, okay? This is the smallest me that you can get. If you want to cut me down into another size, you can no longer get me. What you are going to be getting is the pieces of me. Okay, so you can't get to, if you take my head away, take my hands away, take my mouth away, then I am no longer me. Okay, so that is an atom. Let's look at another term that is very key, very important for us to consider, and that is the term element, 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 element. Now look at these balls that I showed here. Okay, we have the oxygen, the sodium, the nitrogen, the chlorine, and the hydrogen. Okay, all these are what are elements, right? But if you look at them individually, oxygen, represented by this blue button, is definitely different from sodium. And of course, sodium is definitely different from this nitrogen, the yellow, and that is definitely different from chlorine. Okay, that's the purple. But if you look at them individually, all atoms of oxygen will look exactly the same. All atoms of oxygen will look exactly the same. And the same thing goes to all atoms of what? All atoms of hydrogen. It will look the same. So that goes to tell us that an element, okay, one particular element has a distinct characteristic from another word, another element. So therefore, how do we cook up, or how do we describe an element? Does any of you want to give it a shot? How would you describe an element? Any of you want to give it a shot? Someone? How will you describe an element? How will you describe an element?
An element is a simple substance that cannot be broken down by chemical means and consists of atoms.
Cannot be broken down, okay, by any chemical means. That's a fantastic response. That's a fantastic response. Okay, somebody said an element is two or more of atoms. Okay, an element is a combination of atoms. So we'll try to moderate that, okay? I got a definition. Someone said an element cannot be broken down by any chemical means into other simpler substance. Okay, good. That's brilliant. But looking at the response I'm getting from the chat room, it says an element is the combination of atoms. We need to look at it critically. Combination of atoms. In what sense are you saying combination of atoms? So consider that. There's someone say, Angela, two or more of atoms. That is not too clear. Okay, maybe you want to rephrase. Okay, maybe you want to rephrase. So looking at this, describing an element, okay, yes, an element is a substance that cannot be further broken down or divided by any chemical means. That's correct. But we can also look at an element in another form. Brilliant. I'm getting another response. It says an element is a substance that is made entirely from one type of atom. That is fantastic. Mayoko, that's a fantastic and brilliant response. Okay, so let's marry the two definitions we'll look at now together. And elements cannot be further broken down. What that simply means is that if you split this oxygen, you are not going to get another atom from an atom of oxygen. Okay? It means you have decomposed that oxygen. You break it down, you can't get another atom. Now let's look at the concept of purity. Let's look at it from the point of angle of purity. Someone said an element is made up of only one type of what? Only one type of atom. So if you look at this that we on the board here, this oxygen atom, okay, this oxygen atom is made up of a type of atom that is similar to this. They are similar in nature. This sodium, okay, has a type of atom similar to this. Okay, this chlorine has a type of atom similar to this. So we can call them one element. So the simplest way to look at an element is to see an element as a pure wall, a pure substance. That definition, you cannot go wrong. It's a pure substance that consists of only one type of what? Atom. Okay, do we get that? It consists of only one type of what? One type of atom. Now, let me show us this. Let's see this. Let's see this. Now, look at what we have here. Look at what we have here. Look at what we have here. Okay, so can you see this? This is oxygen. Okay, I have oxygen here. This is an element based on our definition, very pure. But can you look at this? Look at this. Can you tell me whether this is pure or not? This one that I just circled, that I called A, is A pure or not? Who wants to tell us? Is A pure or not? Brian, is A pure or not?
Sir, I don't think A is pure.
Okay, good. So you want to tell us why don't you think it's pure?
I don't think A is pure because it's a combination of two elements.
Brilliant. You can see that it's a combination of two. Okay, it's a combination of two. It's not pure. So it means that this is not what? An element. It is not an element at all. So if you look at this other one too, this is not an element because you can see here, I use the color code to represent the various atoms. Because it is not pure, okay, then we can't call it what? An element. Okay, so therefore, it seems to appear to us that an atom, okay, every element, okay, has its specific type of what? Atom. So this is sodium. This is an element. This is not an element because we can see that two or more things are combined here. This is not an element. We can see that two or more things are combined. But here, this is an element. It's just pure on its own. That's an element, consists of only one type of atom. Okay, so when a chemist use the word element and when they use the word atom, we need to put it in context. What are they referring to? Okay, so let's look at another accent that they use, another terminologies that a chemist use, and that is molecule. That is molecule. Okay, so if you look at this illustration here, this is hydrogen atom combining chemically with another hydrogen atom. Okay, now that combination, will somebody tell us, is this a physical combination or a chemical? How are they joined together? Is it a physical combination or a chemical combination? Yes, someone? Chemical combination. Yeah, thank you, Simisola. She said chemical combination. Yes, Abisola, correct. You're correct. That's brilliant. She said they are joined chemically. They are joined chemically, okay? So that's a chemical word combination. Now, why do we call it molecules? Molecules. Anytime you have two or more types of atoms joined together, anytime you have two or more types of atoms joined together, what you have will be a word, a molecule. Two or more types of atoms joined together, it gives rise to a molecule. So you call it a molecule because there is a chemical combination of what? Of atoms, of elements. Chemical combination of atoms or elements. Okay, good. So now I want someone to suggest, how could molecules be joined together? Is it possible to have molecules of the same type being joined together? Or is it only molecules of different types that are joined together? Yes, who wants to respond to that?
Could you please repeat the question?
Yeah, what I'm saying is this. I'm saying that we said molecules consist of atoms joined together. Then I'm saying, what are the various ways these atoms could be joined together? Is it only this form in which you have hydrogen, for example, joined with another hydrogen? Or can we have different types of atoms being joined together? Is it possible to have different types of atoms being combined together in a chemical bond? Or is it only atoms of the same type that can be joined together? Wow, Simisola said atoms of both the same type of molecules, okay, and different types can be joined together. Okay, okay. So let me rephrase that. Both the same type of atoms or different types of atoms can be joined together, okay? Because molecule in itself suggests that you have atoms of different what? Different elements that are being joined together, okay? So now we need to begin to use the right terms very well. You need to begin to speak. When you need to mention elements, you mention elements. When you need to mention atoms, you mention atoms. When you need to mention molecules, you mention molecules. So from what Simisola said, we can see here that she's saying that it is possible to have different mix. You could have atoms of the same type joined together. You could have atoms of different types joined together. So let's see and dive into having molecules of the same type of atoms joined together, okay? And we'll see what name we could give to them. Molecules of the same type of atoms being joined together and the different names that we can what? We can assign to them, okay? So let's see. Yes, quickly, someone should give me an example of a molecule. Just give me an example of a molecule. An example of a molecule. Or you could pick from this slide. You could pick from this slide. You can see atoms of the same elements here are being joined together. This is oxygen. We have same elements joined together. This is nitrogen. We have same element joined together. Okay? Same element joined together. This is sodium. We have same element joined together. This is hydrogen. We have same element joined together. Then we also have same element joined together. So it is possible to have atoms of the same element going into chemical interaction with one another. Okay, so if you look at this now, I want to ask a question. Can I call this an element? This is a molecule. Why is it a molecule? Because I have two atoms of oxygen chemically joined together. As long as atoms are chemically joined together, I will call it a molecule. But is it possible for us to say this is also an element, or is it wrong to say this is an element? Here I have atoms of oxygen joined together with an atom of oxygen. So the chemical formula for this will be what? So let's suggest the chemical formula for this combination. Yes, tell me, Sola, please. Yes, just tell me the formula you want to tell and tell us whether it's an element or it's just a molecule. Yes,
no,
please, go ahead.
I wanted to ask a question.
Okay, go ahead, please.
About the molecule thing. So what's the difference between like a molecule and an element that exists as a diatomic element?
Element that exists as diatomic. Brilliant, brilliant. So we are saying that in nature, okay, how do some elements exist in nature? Okay, oxygen, for example, exists as oxygen gas. Okay, that's why initially I started by saying chemistry as life around you. Okay, it exists as oxygen gas. And because it's an oxygen gas, it is not an individual atom, okay, that represent oxygen. It's oxygen molecule. So like somebody gave us the answer to oxygen in the chat room. It says that oxygen formula is O2. You can see that. So O2 is oxygen gas. Anytime they mention the word oxygen gas, they are simply referring to oxygen molecules. So what is a molecule? A molecule is formed when two or more atoms are chemically joined together. Okay, now we are looking at an example in which two atoms of the same element are joined together. Two atoms of the same element are joined together, and that gave rise to what? To that oxygen. Okay, so oxygen is diatomic because a molecule of oxygen consists of two atoms, 1 and 2. That is why it is what? Diatomic. Can you see that? A molecule of oxygen consists of what? Consists of two atoms. So if a molecule of an element consists of 3 atoms, then we'll say such a molecule is triatomic. Okay? So now, for knowledge sake, everybody, cast your mind back to the periodic table. Cast your mind back to the periodic table. Okay, in the periodic table, we have how many groups do we have? Quickly, just say it randomly. How many groups do we have? 8 groups, 8 groups. Brilliant. That 8th group are also called group what? 8th group of elements are also called group what? What other name can you call the 8th group of elements? Yes, please. Noble gases. They are called noble gases. Brilliant. Thank you, Oyewo Toluwani. Noble gases. Or you call them group 0. We'll soon get to that. Group 0. Such, gases are monoatomic. They are monoatomic. Memuna, thank you for your response. You are correct. Absolutely correct. They are called group 0. Okay, such group of elements, okay, they exist as monoatomic. That simply means that they do not form molecules. They exist as individual atoms. So answering Temisola's question, diatomic molecules, okay, consists of 2 atoms per molecule. Very simple. Consists of 2 atoms per molecule. Okay, so let's write down on this. We can see here that we have been able to mix 2 atoms of the same type together to form a molecule. So this is a molecule of oxygen, this is a molecule of nitrogen, and the formula will be N2. Okay, now this is a molecule of hydrogen. The formula is H2. This is a molecule of chlorine. The formula is Cl2. Now the question is, can I call O2 an element? Can I call O2 an element? Okay, I'll put this formula inside this box. I have O2, I have H2, I have N2, I have Cl2. Is it correct to call each of these an element? Yes, who is answering?
No, it's wrong.
It's wrong. Okay, you say it's wrong. Why do you say it's wrong? Yes, there is no wrong or right answer, but as long as you can defend your answer. Okay, so I'm seeing the chat session. Abisola said, no, we can't call it an element. Simisola said, no, we can't call it an element. Olatubosun said, no, we can't call it an element. Okay, so, yeah. Why do you say we can't call it an element? Yeah, before I make you experience chemistry now. Why are you saying we can't? Well, for me, I think it depends. Okay, Menoma, you said it depends. Can I hear you? Can you explain? Abisola said these are gases. Okay, it's a combination of 2 atoms. Okay, so that is why it cannot be an element. Okay, good. Now, it's a molecule. Okay, Olatubo said it's a molecule. Brilliant. Okay, I've gotten your response. You guys are one of the most fantastic set of students I've ever met. I like your responses. You guys are very energetic. Let's keep it coming. Okay, oxygen is an element on its own. Okay. Oh, good. Okay. Somebody said that in the chat session. So I think I agree with that person. Menuma, I agree with you. Now, everyone, I need your absolute silence. I need you to gaze at me as I tell you this.
So what you want that to do now is to send the mail to...
Okay. So each of these that you saw on the board, okay, can be called an element. Let us cast our mind back to the definition of an element. We said an element consists of only one type of what? Atoms. Only one type of atoms. So if it consists of only one type of atoms, then
well, if I call it, the person I want to call,
you will agree if it consists of only one type of atoms. Okay, it consists of only one type of atom. So you agree with me that oxygen, let's look at this oxygen. How many types of atoms do we have here in oxygen? How many types of atoms do we have here in oxygen? How many types of atoms can you see there?
2.
Huh?
2.
2. Okay, one more response. 1. Simisola said 1. Gabby said 2. Okay, so let's look at that. So I need to clarify something here. There is a difference between types of atom and how many atoms. If I'd had the question, how many atoms are present, you will say 2 atoms. But if I say, how many types of atoms, it's only one type. I only have one type of atom 2 times. Gabriela, did you get that?
Yeah.
Okay, so here I have only one type of what? Atom, and that is what? Oxygen. That's why I used color to code it. You can see the only color you have here is blue. So it's only one type. Now, let's go back to nitrogen. For nitrogen here, How many types of atoms do I have here in nitrogen? Going by the same explanation, I have only what? One type. That is what? Nitrogen. So that makes it what? That makes it an element. Okay? So it is both, each of these is both a molecule and what? An element. Just like I am both an African and a Nigerian. Okay, so we are simply saying that each of these is molecule of an element. So you call them molecules of what? An element. So this is a molecule of an element. Okay, this is also a molecule of an element, hydrogen. This is also a molecule of an element, nitrogen. This is also a molecule of an element, chlorine. So a molecule consisting of only one type of atom will be called the molecule of an element. Okay? So always remember that an element is pure. That's the easiest way that you won't mix it up. An element is a pure what? Is a pure substance that contains only one type of atoms. But a molecule, okay, is formed when two or more atoms are joined together. In this case, we have seen a situation in which a molecule consists of only one type of atoms. It's just that we have two of such, or two of the same type joined together. Now, let's look at a situation in which different atoms are joined together. Situations in which a molecule is formed by different atoms being joined together. And this is where you make a full sense of it. So let's look at that. Let's look at it. Can you see this? Can you see this? Okay, so I take this first one, right here. How many atoms do I have in this molecule? Of course, you agree with me that this is a molecule because atoms are joined together. So that makes it a molecule. But how many atoms do I have here? How many atoms do I have? Yes, please. How many atoms do I have? 3 atoms. Oluwa Mumiyo said 3 atoms. You are correct. Fantastic. Olatubosun, 3 atoms. Brilliant. Yeah, you guys are getting the explanation. Yeah, brilliant, 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 brilliant. So we have 3 atoms. Now I want to ask another question. How many types of atoms do we have in the one that I circled in red? How many types of atoms do we have? How many types of atoms do we have? Yes, Oluwamumiyo said 2 types. Good. Angela, brilliant, said 2 types. Abisola said 2 types. Good. Now you guys got that. So you can see here, now if you have 2 types of atoms chemically joined together, what do you call it? Can you still call it an element? Can you still call this an element? When you have 2 types of atoms joined together, can you still call it an element? Oh, Angela, brilliant. Angela said, no, you can't call it an element. In fact, she told us that it is called a compound. Angela, thank you. She said it is called a what? A compound. It is called a compound. Okay, so how then do we define a compound? Based on this line of explanation, how then do we define a compound? How then do we define a compound? Yes, please. Good. Okay, it says the first one is a compound. Yes, brilliant. Oluwa Busola, that's correct. That's correct. That's a compound. That's a compound. It's correct. It's correct. That's a compound. Okay, 2 or more different types of atoms chemically combined. Fantabulous. Thank you, Angela. She said that a compound is formed when 2 or more types of atoms are chemically combined. So let's see how that her definition fits into the diagrams that we have on the board. Okay, Olatubo also said a compound is a substance consisting of two or more elements chemically combined together. Brilliant. Oyewa said a compound is made up of two or more elements, two or more types of elements. Please always put types there, two or more types of elements. So Oyewa, rephrase your sentence. A compound is made up of two or more types of elements, two or more types of elements, okay? Yeah, Usondo Matthew says a compound consists of two or more elements chemically combined together. Chemically combined together. So you can see now that all these ones are compound, right? So let's look at this particular one. This is also a compound because we have two different elements here. Nitrogen is different from hydrogen. Because you have different things chemically combined, you call it a what? A compound. Isn't it that simple? So this is also a what? A compound. This is also a compound. Even though this looks so simple, it's also a compound because it consists of at least two different types, hydrogen and chlorine. So we can as well quickly state the formula of this. That is H2O, right? Okay, 2 hydrogen, 1 oxygen. Okay, let's look at this one. Yes, in the chat session, you want to type the formula for this. Let me label it A, B, and C. A, B, and C. So type the formula for A, B, and C in the chat session. Good. And if you want to say it orally, you can unmute yourself and say it. The formula for A, B, and C. Yeah, quickly. Quickly. Yeah. I'll read your charts. Just keep it coming. Keep it coming. Okay. Okay, good. So, yeah, brilliant. B is HCl, you are correct. And C is carbon dioxide. Brilliant. That's a brilliant response. It's carbon dioxide, you are correct. Carbon dioxide. Okay, what about A? What about A? The first one. Carbon dioxide. Okay, Simisola, you said ammonium. Can you check it again? Check the number of hydrogen there. Check the number of hydrogen present. Simisola. Check the number of hydrogen present.
There are 3 atoms of hydrogen present.
Okay, thank you. So it can't be NH4. It has to be what?
NH3.
Correct. Brilliant. NH3. Well done. NH3. That's ammonia. And HCl. Okay. So when you are writing the formula, HCl, okay, that L is small letter. Please be mindful of that because in exam, you will not be pardoned. That L is what? Small letter L. Brilliant. So let's quickly move on. Now, spot the difference here. You need to spot the difference in this. Okay, it's coming up. Okay, so spot the difference in this. Is it changing? Okay, spot the difference. Good. So look at it now. Let's use this to now refresh and put everything together in perspective. I think with this, it is clearer now. No more misconception. Okay, molecules of an element, you can see that. So each of these is a molecule of what? Of an element. Each of these is a molecule of an element. So you can see this is a molecule of what? Oxygen. Okay, this is a molecule of what? A molecule of nitrogen. This is a molecule of what? A molecule of hydrogen element. This is a molecule of chlorine element. But when it comes to this other side, you can see, even though this is a molecule, but it is a molecule of a compound. Can you see that? This is also a molecule. It is a molecule of a compound. This is also a molecule. It is a molecule of a compound. And this is a molecule of a what? A compound. So now you can see that a molecule could either be an element or a compound. When can it be an element? If you have only one type of atom, then it will be molecule of an element. When can it be a compound? If you have two or more types of atoms chemically joined together. Okay, good. I hope we are making progress, right? Are we making progress?
Yes.
Okay, good. Now, what about ions? What about ions? It's getting deeper now. What about ions? When you talk about ions, what are we referring to? What do chemists talk about when they talk about ions? Virtually a lot of topics that you have to deal with. The ions to the foundation. Okay, good. Olatuboso said ion is a charged atom. An ion is a charged atom. Good. When we say an ion is a charged atom, like charge, what do we mean? Does it mean that you put an ion, okay, in your, or you connect your phone charger to the ion and put it into the socket? How can an ion become charged? We said an ion, okay, is a charged particle. An ion is a charged particle because it is possible for an atom to be charged. It is also possible for a molecule to be charged. Okay, it is possible for an atom to be charged, that is just only single representation of an element, that's an atom. It is also possible for a group of atoms to be charged. So that is why we don't say an ion is a charged atom. Okay, we just say an ion is a charged particle, depending on the particle you are talking about. Now, everybody, I need you to understand this now, that in chemistry, a particle could either be an atom, okay? A particle could either be a molecule, okay? A particle could either be a compound, okay? And a particle could be ions itself. Okay, so the word particle simply means substance. Now, if you look at the board, I have a neutral atom here, a neutral atom. We want to look at what is the difference between this atom that is neutral and this atom that is charged. Okay, so what is the difference? We can see that something must happen to an atom before it becomes charged. So there are two things that could happen. It's either the atom loses electron, or what? Or the atoms what? Gain electron. It's either it loses electron or it gains what? Or it gains electrons. So I need you to put that two things in mind. Don't worry, you will get it. Just put the two things in your heart. Now, an atom, a neutral atom, could follow two paths. It could become positively charged or what? Negatively charged. For it to become positively charged, what will it do? It will lose electron. For it to become negatively charged, what will it do? It will gain electron. But rather than memorizing it that way, is there a way we can have a thorough understanding of what actually happened at the atomic level, such that you won't have to do guesswork, such that you won't have to forget about this again? Now, let's dive in and see how you can remember this without you struggling. Okay, good. So how can you remember this without struggling about this?
Mr. Ogutoye?
Yes, please.
Oh, okay. I just wanted to say something I used to remember.
Okay, please go ahead. That's brilliant. Go ahead, please.
Okay, so what I think about, because electrons are negative, so what I think about, if something is gaining electrons, that means the thing is gaining something negative.
Oh,
So
brilliant.
And when something is losing electrons, then it's losing something negative. Then it will be positively charged or negative.
Yes, absolutely, absolutely. That's a fantastic way to look at it. Yes. See, I encourage every one of you, just use what works for you. Okay, as you are unique individually, you have unique learning styles. You have some things that you can use that will work for you. Now, one of the strategies I use is by association. Like she said now, that is the principle of association. You associate what you know with something you are confused about. She said that she sees electron as something negative. And of course, electrons are negatively charged. So if I'm gaining negative to myself, over time, I'll become what? I'll become negative. I'll become negative. Okay? So imagine me losing something that is negative. If I'm losing my negative energy, I'm losing my negative energy. I'm losing my negative energy. Over time, what will I become? Will I become more positive or more negative?
More positive.
I'll become more positive. So that way you will see, you'll be able to remember how positive ions are formed. Positive ions are formed when a gentle atom on its own loses negative energy. This negative energy is what? Electron. Okay, so when it loses electron, it becomes more positive. But if you have an atom that is not wise, but goes ahead to gain negative energy to itself, over time, what will happen to this particular atom? It will become more negative. Temisola, that's a fantastic and brilliant idea. Thank you for sharing it with the class. Okay, so now let's look at one more thing, idea that could help you to remember that. Why will an atom carries a positive charge even when it has lost electron? Yes, we know it has lost electron, but why will it carry a positive charge? I want every one of you to focus on the board now. Sodium, okay, good. How many electrons do we have in sodium? You may want to count from my board if you like, if you have forgotten. How many electrons do you think sodium has? How many electrons?
10.
Okay. Hello, listen, baby, before coming. Never offend Felix Nelson. 10, is that 10? Do you want to check it again? Yeah, try. You're almost close. Okay. Angela said 11. Oluwabusola said 11. Olatubosun said 11. So you guys are correct. It's 11. Sodium has 11 electrons. Okay. 11 electrons, right? So if it has 11 electrons, now let's now do a calculation. Okay, so permit me to write first number of electrons. We said it's 11, right? Mm-hmm. Good. Now, 11 electrons are negatively charged. So this should be 11 minus, isn't it? Right? Do you agree with me to be 11 minus? Because electrons are negative. Good. Now, protons. How many protons do you think it will have? How many protons do you think sodium atoms will have? How many protons? Yeah. Yes. How many protons with sodium atoms?
11.
Somebody said 12. Somebody said 11. What's the atomic number? Proton number equals to atomic
11.
number. 11. Okay, 11. Now, one of the ways to look at it is this, and from this you will not mix it up again. You'll notice that an atom is neutral, right? When you say something is neutral, it means that it does not have any charge. So why is an atom neutral? Why is an atom neutral? Let's look at the number of electrons against the number of protons. 11 plus against 11 minus. What will be your net charge? What's the net charge?
Plus. 0.
0, brilliant, 0. 0. That is why an atom is neutral. Because in an atom, the number of protons will be equal to the number of what? Of electron. Okay? Number of proton will be equal to the number of what? Number of electron. Do you get that? Good. Now, this sodium atom decides to lose an electron. It decides to lose an electron. So if it has lost an electron, then it is forming an ion. For this particular ion, can we check the number of electrons against the number of protons? That's what we want to do now. Let's try to compare the number of electrons to the number of protons. This guy has lost an electron. How many electrons will be left in it?
10.
How many electrons will be? 10. Okay, so we are going to have 10 minus, right? 10 minus. Now, the proton, how many protons do we have? How many protons?
11.
11. So the protons remains the same, right? So let's find the net charge. Now let's find the net charge. What do we get? What is the net charge?
+1.
What is the +1? +1. That tells us that the sodium ion will carry a positive charge. That is why sodium carries a positive charge. And in this case, your sodium will be written as sodium plus. That means it has +1. It carries a positive charge, +1. Isn't that amazing? Okay, so if you look deep down into the subatomic level, you'll be able to explain why a particular atom changes to plus or why another atom changes to minus. Okay, so in this case now, looking at a subatomic particle, we can see that sodium carries a positive charge because it has lost an electron. Now sodium has one more proton than electron. So sodium is positively charged. Good, good, good. So let's consider a situation where an atom becomes negatively what? Negatively charged. I want somebody to explain this. Somebody, you explain this for us. You tell us the number of protons, number of electrons for atom and for ion. As you are saying it, I will help you write it on the board so that others can follow. So who quickly want to do that? Who quickly want to do that? Who want to do that? Yes. Anyone want to do that? Quickly, 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 quickly. Tell us how this particular chlorine neutral atom will change to ion using the number of electrons as against the number of protons. Yes. We'll calculate the number of electrons in it as against the number of protons. Yes, who is doing that?
Okay, can I try?
Number of electrons. Okay.
Okay.
And don't worry,
Abisola, right?
go.
Yes, is that Abisola? Yes, go ahead, please. Go ahead. I'm listening.
Someone was about to say something, so she can go.
Yes, go ahead, please. Yeah, Abisola, right? You can talk. We are listening.
It wasn't Abisola, it was someone else.
Okay, please. You can talk, please. I'm trying to find the name of the person who was. Okay, please go ahead. Go ahead and explain, please. Okay. Oh, Jesse, how are you, Jesse? Jesse, how are you? Okay, so Abisola, you want to explain?
Okay, I'll just explain then.
Okay.
So chlorine's atomic number is 17. So you have 17 electrons and 17 protons.
Okay, 17 electron. Chlorine is 17 electron minus. Proton is 17 what? Plus or minus?
Plus.
Plus. Okay, so I put plus there. Good. So what is the overall charge?
0.
What's the overall charge? 0. Good. Now, this particular chlorine, what has happened to it? Do you want to explain?
Yeah, it has gained an electron.
Okay, so it has gained an electron. Yes. Go ahead, I'm listening.
So when it gains an electron, the electron becomes 18, I guess.
Okay. Okay, so E is equals to 18, right?
Yes.
18 minus, okay, sorry. Okay, 18 minus, it becomes 18 minus, good. Now the proton becomes what?
It's still 17.
17, good. So by now, I think everyone should be able to understand what charge it will carry. What will be the next charge? What will be the next charge?
It'll be negatively charged. Because
negatively charged. It will be negatively charged. By how many?
By 1.
By how many? By 1. So it will be -1. So understandably, you can see why chlorine is what? -1. Okay? So this is the fundamental reason behind the charges that any particular ion carries, whether it's going to be plus or what, or minus. Okay? Good. Any questions so far? Okay, good. Okay, so before we proceed, okay, for those that are preparing for the WAEC exam coming, I think in a few weeks' time, we are going to be having online practical session for the WAEC students on Zoom, okay? It's going to be a preparation towards your WAEC. I tell you, if you attend that class, you're a WAEC student, your A is sure, okay? So we are going to be announcing the dates that it will be coming up, okay? Just stay tuned, okay? If you're a WAEC student and you join this particular class without registering, just make sure you check the registration link and register, okay? So that we can have your email, so that when we want to have the class, you get the information. Just make sure you stay what? You stay tuned, okay? Good. For WAEC student, preparation towards your practical exam, we'll be having it in few days from now, okay? So we'll be announcing that to you, okay? So before the class ends, I'm going to be dropping a contact so that you can send message to confirm when the class will be, okay? Towards your practical, chemistry practical exam coming up, okay? Is that taken? Good. So let's proceed. Let's proceed. Now, we have looked at these various case and situation where scientists or chemists use certain terms, atoms, elements, molecules, compounds, and all that. Okay, so I want somebody to reiterate what you have learned so far, or what you now have a better understanding of. Okay, just in 1 minute before we continue. Then somebody's just joining again. I will do the announcement again, then we'll move on. So I want somebody to tell us what's something new you have learned, or something that was confusing that you now have a better understanding of, so that others who can learn from you quickly. Yes, you can unmute yourself and say it quickly. I'll take 1 or 2. Yes. Yes, anyone? Anyone? Quickly. Okay.
Mr. Guntere?
Yes, please.
Okay, so you've clarified the meaning of molecules and the difference between molecule and elements and compounds.
Okay.
So that's something I've learned.
Okay. Okay. Good. Miss Aneke. Miss Aneke, are you still with us? Are you still with us? Okay.
Yes, Mr. Gunsoye, I am. Sorry,
okay,
I was trying to unmute.
Yes, I know that over the years as you teach, you've come across some misconception that students regularly make with respect to this use of atoms, ions, molecules.
Yes, I have.
Do you want to just say something quickly? Give an example and clarify.
Yeah,
Yes.
What I want to clarify is about negative ions. Okay. When atoms gain electrons and form negative ions, they change their name. All right. So we don't refer to oxygen ion as oxygen ion. It is referred to as oxide. Okay. So whenever you come across a negative ion, have it at the back of your mind that the name of that ion would be derived from its original atom's name, but this time around the name will end in IDE. So what do I mean? Oxygen, for example, would gain 2 electrons to form oxide ion. So it would no longer be called oxygen ion, but oxide ion. All right. Chlorine would gain 1 electron to be called chloride ion. Nitrogen will gain 3 to be called nitride ion. And it keeps going on and on and on like that. So there's nothing like sulfur ion. It is sulfide. There's nothing like bromine ion. It is bromide. Okay, take note of that. I know that's one misconception. They'll tell you bromine ion. No, it's bromide, not chlorine ion, chloride. Is that clear? So, Mr. Oguntoye, that's all I want to contribute for now.
Brilliant. Thank you so much. Yeah. So you guys, you can see that's a fantastic contribution. It's actually one area that students mix up. So if you can see the board now, okay, from what Ms. Aneke just told us, you can see whenever your oxygen, okay, forms negative ion, what will it be called? It's going to be called oxide ion. Okay, so you want to be writing that down. Your chlorine will form what? Your chlorine will form what? Chloride what? Ions. While your nitrogen will form what? Nitride ion. Nitride ion, IDE. Please note that. Your sulfur usually form what? Sulfide. Sulfide. While bromine forms what? Forms bromide. These are just a few examples of your non-metal when they change their name. Okay, so the metals don't change their name. Metals retain their name. So we are going to be looking at a marriage ceremony very soon. Okay, so you'll see usually why in African setting, when the lady gets married, she changes her name. Okay, why the man retains a name. The same thing with non-metal. When non-metals, gain electrons and they become attached to a metal, they will change their what? They will change their name. So oxygen becomes oxide, chlorine becomes chloride, nitrogen becomes nitride, sulfur becomes sulfide, and bromine becomes what? Bromide. It goes on and on. Okay? Yeah. Thank you so much. So for those who just joined us, okay, we're saying that in a few days from now, the chemistry WAEC exam will be coming up, and we are going to be organizing an online class towards the practical exam for those writing WAEC, okay, towards the practical exam. Please make sure you do not miss any of these this opportunity, okay? We're going to be dropping contact at the end of the class in case you have not registered before joining this class. Okay, if you register, it means we already have your contacts. We'll be sending information to you, okay? Success is yours, and I'm pretty sure you're going to get all the A's that you need, okay? Good. Now, why do atoms form bond? I've looked at the fact that it is possible for molecules to be joined together, okay? So why would they want to join together? Why won't an atom want to remain the way it is? Why would an atom want to join with someone? Okay, why would an atom want to join with someone else? That's what we want to consider. Why do atoms form bond? Why don't they just remain the way they are? Okay. First, can somebody describe for us what you think the life of nobles look like? You know, people we call nobles, the royals, okay, the obas and the priests. Do you want to tell us what their life look like? The nobles. What the life of nobles look like? Anyone? Who is giving that a shot? Want to describe the life of nobles? Yeah. The obas, the royal people, compare their just say something about their usual lifestyle.
I think, sorry, good evening, sir. I think that the life of nobles is that they live in, like, they are respected by people a lot, and they live really in big houses and stuff like that. They have a lot of responsibility on them, and they are very special people who don't usually do things as usual people.
Okay. So nobles, from what she said, we can say that there are people who enjoy, right? They have you know, they have so many things to enjoy, so many things at their you know, call. Okay, those are nobles. So we can say essentially that nobles are, we can say they have everything that they need. They have everything that they need. So we can say that nobles are what? They're complete in a sense. They have everything that they need. And every one of us want to live the life of royals. Okay, you want to be celebrity. You want to have everything you need. You don't want to have any cause for concern at all. But do you know that even atoms want to have everything that they need? They do not want to be in lack at all. Okay? So in an attempt for them to have everything that they need, atoms go out of their way to either lose electrons or what? Or gain electron. So how do I mean? If you look at the periodic table, okay, we have a set of atoms or set of elements that we call noble gases. Which group do they belong to? Which group do they belong to?
0. Group 8.
Group 8 or group 0. Now, this group of elements, they have everything that they need. So I want you to look at that word noble as royalty. Okay, the Prince of Cambridge, the Duchess of Cambridge, you know, the Emir of you know, whatever country or whatever state. Okay, they have everything at their call and beckon. I actually wanted to show you a video of how some emirs enjoy, but my video was not coming up, but it's fine. Okay, so these are noble gases. They have everything that they need. Now, this everything we are talking about, let's call it money. So currency. The currency that atoms have is what? Electron. So if you look at noble gases, something is common to noble gases. Who want to tell us what is common to all noble gases? What is common to all noble gases?
They are all gases.
They are all gases. One.
Their outermost shell is full of electrons. That's it.
Brilliant. They have full outermost shell of what? Of electron. Full outermost shell of electron. So essentially, this is what we are saying. We are saying that if you look at the noble gases, the first guy here is helium, right? Helium has 2 electrons, and the 2 electrons are in its what? Outer shell. The 2 electrons are in its outer shell. Okay. Now the next noble gas is what? If you know your periodic table offhand, the next noble gas, neon. What's the number of electrons it has? Neon. What's the number of electrons?
10.
The number of electrons? 10. 10. But how many does it have in its outer shell? How many does it have in it?
8.
8 in its outer shell. Brilliant. So let's look at the next guy there. What is the next guy? Okay. Argon, right? Okay.
Argon.
So it continues like that. Okay. All these elements, something is common to them. Okay, apart from helium, tell me something common to these three elements. Look at their outer shell. Look at their outer shell. What is common to them?
They all have eight.
They have
Brilliant.
the same number of atoms shell.
They have 8 atoms on their outermost shell.
8 electrons, you mean, right? They have 8 electrons in their outermost what? Outermost shell. Now, do you know that having 8 electrons in the outermost shell for an atom, it means that that atom has arrived. That atom has assumed a noble status, and that status makes such an atom to be what? To be stable. See, it's very rare for you to see an Oba or a king on the road. They are rare people because they are stable. They don't hustle. Kings don't hustle. Let me use that word. They don't hustle like regular people like us. Anyway, I'm a prince anyway, so I hustle less too. So noble gases, okay, don't hustle. They have complete outer shell of electrons, so they are stable. So I need you to keep that connection. What makes an atom become stable? When such an atom has what? A complete outer shell of electron. Okay? Now, having complete outer shell of electrons could be in 2 forms. Number 1, it could be duplets or octets. So we have just one atom that has complete outer shell, and it is called duplex configuration or duplex electronic structure. And that is what? Helium. You can see helium, it has only 2 electrons in the outer shell. Duplex configuration is stable. Okay, why all other atoms have 8 electrons in their outer shell, and that is called octet configuration. This comes out in your objective, especially the WAEC objective a lot. Okay, it's the octet what? Configuration. So it makes an atom become what? Become stable. Okay, having said that, we have said that atoms want to become like noble gases. So let's assume I am an atom. I know that I need to become like noble gases. But the question is, how do I become a noble gas? How do I become a noble gas? What are the steps I need to take for me to become a noble gas? Okay, so for an atom has someone like a consultant that told that person, oh boy, if you want to become a noble gas, you need to do these 3 things because you have only 3 choices. To become a noble gas, you have 3 choices. You can either, number 1, lose your electron to other atoms or group of atoms. Please, I need you to note this. There are 3 choices, okay, that an atom, okay, has. 1, to lose electron. Number 2, to gain electrons from other atoms. Number 3, the atoms could decide to share electrons. So I reiterate, I could decide to lose electron, I could decide to gain electron, I could decide to share electrons. Good. Now, let's assume I've been told these 3 things to do. Then I want to try them out one after the other to see the one that favors me. So join me in this journey. Let us try these 3 choices for a particular atom, and let us see whether the atom will be able to become a noble gas or not. Are we ready? So let's go in and see. Okay, so look at this. This is an atom. Okay, this is an atom, sodium. Sodium want to go by choice number 1. Choice number 1. And what is choice number 1? Choice number 1 is what? Losing electron. That is choice number 1. Losing what? Electron. So the electronic structure of sodium is what? 2 8 what? 1.
1.
That is your 1s2, 2s2, 2p6, and what? 3s what? 1. Okay? My white guys understand what I just wrote, okay? That's another way to write the electronic structure. Just count the electrons on top, okay? Count the electrons on top. We have 2 plus 2, 4, plus 6, 10, plus 1, 11. That's all, okay? So we have 2, 8, 1. That means that sodium wants to lose electron. So let's assume, following by the first choice, sodium has lost the last electron in its outer shell. Okay, so sodium will become this, right? Everybody, sodium becomes what? This. 1, 2, 3, 4, 5, 6, 7, 8. So count with me, everybody. How many electrons do we have in the outer shell of sodium now? Because it has lost electron. 1, 2, 3, 4, 5, 6, 7, and 8. And 8 quickly. Okay, so you can see it has 8 electrons in its outer shell. So by losing an electron, sodium as what? Has attained a noble gas. Sodium is now looking like a what? Like a noble gas. But another issue is this. Sodium is further confused. Sodium does not know. In losing electrons, sodium is asking further questions. How many electrons do I have to lose? Then, who is going to lose the electron? Is there any guiding rule? So we are now saying we have various elements in the periodic table. We know that by losing electron, an element can become a noble gas. But we are asking the question, then how many electrons will an atom lose? How many electrons will an atom lose? And number 2, who is going to lose electron? Is it a metal that will lose electron or a non-metal? Is there any rule that will help us to answer question 1 and question 2? That is what we are looking at now. I want to ask again. In losing electrons, we need to ask the question, how many electrons will be lost? Number 2, who will lose electron? Is it a metal or a non-metal? Is there any guiding rule and regulation? Of course, there is a guiding rule and regulation. Let's look at that rule and regulation. And this takes us back to the periodic table. If you go back to the periodic table, this represents your periodic table. Okay, on the periodic table, we have group 1, group 2, group 3, group 4, group 5, group 6, group 7, and group 8. Okay, group 1 to 3, are they metals or non-metals? Somebody tell us. Group 1 to 3, are they metals or non-metals?
They are metals, except from helium.
Brilliant. They are what? They are metals. Okay. Okay. Helium is actually in group 0. Okay, really. Except for hydrogen, you mean? Okay.
Oh, yeah, hydrogen.
Thank you. Except for hydrogen. Now you can see, I want you to take this as a clue, everybody. If an element is in group 1, okay, and it's a metal, of course, you know group 1 to what? Group 1 to 2, we said they lose what? They lose electron because they are what? They are metals. So if an element is in group 1, the rule is going to what? To lose 1 electron. Okay? It's going to lose 1 electron and become what? Plus 1. If an element is in group 2, the rule is that it's going to lose 2 electrons and become what? Plus 2. If an element is in group 3, it's going to lose what? 3 electrons and become plus what? Plus 3. That is the clue that you need. Okay? That is the clue. Okay, so that's about solves that problem. We'll look at the non-metal later. We'll look at the non-metal when it comes to gaining electrons. So we have seen now that to lose electron, what will lose electron? A metal will lose what? Electron, right? A metal will lose electron. How many electrons will a metal lose at any point in time? It depends on the group that the metal belongs to. If it's in group 1, it's going to lose 1 electron. If it's in group 2, it's going to lose 2 electrons. If it's in group 3, it's going to lose what? 3 electrons. Okay, good. Now let's look at gaining electron. To gain what? Electrons. A non-metal could decide to gain electron, or an element could decide to gain what? To gain electrons. Okay, this is chlorine as an element. How many electrons do we have in this outer shell of this element, chlorine? How many electrons do we have? 7. So if this guy decides to gain an electron from somewhere, the electron goes in and it gains the electron. So the 7 becomes what? 8. You know, initially it was 2, 8, what? 7, right? 2 in the inner shell, 8 in the middle shell, and 7 in the outer shell. So when it gains 1 more electron, it's going to become what? It's going to become 2, 8, what? 8, 8, right? It's going to become 2, 8, 8. Now, looking at it, it has become stable, isn't it? 2, 8, 8 looks pretty much like a noble gas. Okay? Yes, 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 sir. Yeah, I'm checking that. Okay, so it looks pretty much like a what? Like a noble gas. Okay, so let's now see how the rules apply to gaining what? Electron. So we want to see how many electrons will be gained, who will gain the what? Who will gain the electron. So this is the non-metal. Okay, for non-metals, all these are non-metals. All these are they are non-metals, okay? And non-metals gain what? They all gain what? Electrons, okay? So in gaining electrons, the question is, how many electrons will be gained? How many electrons will be gained? If an element is in group 5, who want to suggest the number of electrons it will gain?
2. Sorry, 3.
It's going to gain 3, brilliant. And it becomes 3 what? Minus. If an element is in group 6, it's going to gain 2 electrons and become 2 minus. If an element is in group 7, it's going to gain 1 electron and become what? And become minus 1. If an element is in group 0 does not gain or lose. They are noble. So you can see that an atom becomes what? Will become negatively charged by gaining what? By gaining electron. Okay, so just, yes, please.
I have a question. What happens
please go ahead.
The element in group 4? Do they either lose or gain?
Yes, an element is in group 4 will either lose or what? Or gain what? Gain electron. We either lose or gain electron. It's at the middle. Okay? It's at the middle. Okay, but usually group 4 elements, they are since they are not metal essentially, okay, they share electrons. Like silicon, for example, share electron with oxygen to form silicon what? Silicon oxide. So they prefer to share electrons. Like carbon is in group 4, so they prefer to share what? To share electrons. So they are special group of what? Group of elements. So essentially, we focus on these metals and what? And the non-what? And the non-metal. Okay, so now yeah, our time is fast spent. Okay, unfortunately we will not be able to look at how the atoms come together in a brilliant wedding ceremony. Okay, but what I want to do now, I want to give you guys a short quiz to see how what we learned so far, okay, fit in, and to step you guys a bit, higher. Okay, so if you are interested in participating in the Y chemistry practical class, okay, yes, you can drop your number privately, or please don't put it in the general chat. Send it privately to Coach Adeyemi. Coach Adeyemi is online. He will collate your data. Send it privately to Coach Adeyemi. Don't send it to everybody. Send it privately to Coach Adeyemi. Okay, data safety is very important. Send it privately to Coach Adeyemi. Just check Coach Adeyemi in the chat session. Okay, and send it to him. Okay, or you check me check me in the chat session and send it to me. My name is Larry Oguntoye. Check it and send it to me, or send it to Coach Adeyemi. Okay, good. If you are interested in participating in the coming WAEC chemistry practical class online, okay, send it, your details there. Okay, so let's take a break and take a quiz quickly. Let's take a quiz quickly. I'm going to share something with you now. So I need you to go to the link quickly. You go to it and type in the code so that you can take the quiz. You type in the code and take the quiz. I'm sharing it now. Just look at the screen. Okay. Can you see the screen? Okay, so you may want to type in your browser, depending on the device that you are using. If you are using your phone, maybe a bit difficult, but you can try around that. If you are using your phone, if you go to your browser, the Zoom does not wipe off. The Zoom will still remain there. So type joinmyquizzes.com and type in this code. Joinmyquizzes.com, type in that code 548876. Then I will start the quiz. We all participate in the quiz. Okay? Good. I'm going to be looking for the person that will come top in the quiz. Yeah. I'm going to be looking. I will announce the prize now. But let's look for the person that will come forth.
So it's saying the connection has been closed or something for the join my quiz. I can't seem to log.
Okay. So somebody should type that code. Let me restart that so that you can take that quickly now.
I'm in, Mr. Oguntoye.
You are in the quiz, right?
Yeah. Okay, it's working now. It's working now.
Yeah,
thank you.
It's working. So let me share my screen. Let me reshare my screen. It's working. Please try it. I need you to do it enthusiastically. All the things you have learned, okay, use it to solve the quiz. Okay. Okay. Good. Can you see my screen? If you have not joined, can you see my screen, please?
Yes, we can.
Okay, so I will wait for like 1 minute. 1 minute for everyone to join. I'll wait for 1 minute for everyone to join. Okay. Yeah. Okay, thank you, sir, Mr. Kinusi. Thank you so much. Mr. Kinusi is another fantastic chemistry teacher. Oh my God, you need to meet and be in the class of Mr. Kinusi, Miss Aniki, a fantastic chemistry teacher. Okay, good. They also will be coming up to take 1 or 2 sessions next time that we are going to be meeting. Okay, so thank you, Mr. Kinusi. 548876. Are you guys there?
Yeah.
Okay, so I'm going to start now. I'm going to start it. Even if you are not there, you can still join us. Okay, so, okay. It's telling me that no player is currently in the game. I'm wondering. Okay.
About 5 to 6 players.
Uh-oh. Why is it telling me no player is in the game? Okay, let me refresh then quickly. Let me quickly refresh. Okay. Okay. Good. Okay, I'm refreshing that. Okay, good, I've seen you guys. Good. So let's start. I'm starting. Cool. Go ahead. Let's go ahead. accuracy is very important. Okay, Mayoko, I'm seeing you are second on the leaderboard, but you seem to be choosing most questions wrong. So please be careful. Brilliance. Okay, blessing, you are keeping at it. I love the pace at which you are walking. Temisola is now up first. Cool. It's both accuracy and speed. It's both accuracy and speed. Yes, thank you, Mr. Accuracy, for telling me to refresh. Thank you. I was stuck. Thank you.
You're welcome, sir. Nice.
Yeah. Okay. So, yeah, good. Temisola is sit top. Quick. He. Okay. Others are just say, let me know the challenge you're having. If you cannot participate in this, let me know the challenge you're having. Fatima Dankaka. I think that's from Kano, right? You're welcome, Fatima.
Yeah.
Yeah, from Kano. Yeah, Gida. So no?
Yes, I'm trying to join.
Okay, so just say, let me know the challenge you're having to join. Okay, the code is in the chat session. Yeah. Okay.
Yeah, I'm joining.
Okay. Cool. Usondo favor. It will be nice for you to join this. Okay, or don't worry if you're not used to this. With subsequent time that we'll meet, you'll get familiar with this. All you need to do is to just go to myquizzes.com and type in the code. The questions are already there waiting for you. Okay, so let's see who is going to get the prize. Okay. Yeah. Okay. If you are top on the list.
An error has occurred.
Can you try again? Refresh. Okay. I'm sure you can see my screen, right? Can you see the screen I'm sharing? Yeah. You can see students solving the problems. Okay. Okay, I'm ending the game, almost ending the game because of time. I don't want to take you guys beyond 6. I know you're having a nice time, but we just need to give time the respect. We'll see you meet again some other time where we are going to start with the marriage ceremony of atoms that we are about to look into. Okay, but next time we are going to meet, we're actually going to be the WAEC chemistry practical. So tell all your friends that are doing WAEC chemistry, they need to join this, okay? So I'm also going to drop my contacts, my WhatsApp contacts chat session. Okay, so in case you want to make inquiry, then you can make inquiry. Maybe that would be another option. Or my email address. Okay, you can copy it. Okay. Okay. So you can send email address to that. You can send email address to this. Okay, that's the email address.
Sorry, I can't see it.
Okay, I'll send it now.
I think I'm through the questions.
Okay, so I'll send the contacts. In case you have friends that are doing WAEC, whatever, please send the information around to everybody. Let them send their request to that phone number or to that phone number by WhatsApp or email. We'll let them know. Okay, so let's check now. Let's check. Okay, good. So the game is ending. Okay, so let's check the leaderboard. Let's check the leaderboard and check all the. Yes.
Sorry, sir. Please, can I get the number again?
It's in the chat session. Can you see it in the chat session?
No, sir.
Okay, I'll do that again. Okay, so who is the winner? Oh, yeah, I think virtually everyone tried. Yes, virtually everyone tried. Okay, good. Yeah, that is. I'm trying to open the chat session. It's not Mr. Akinus, you can help me repeat that I sent, please. Thank you, sir. Or Mr. Neke.
I've got it done.
It's done.
Okay. Okay, sir. Yeah. Okay, so wow. Let's look at the question that most of you got wrong. The question that most of you got wrong, question 569. 569. Question 569. Question 5 says, what charge does bromine ion have? Hello? What charge does bromine ion have? We look at that now. -1. How do you know that? Bromine is in group what?
7.
Group 7. Go look at that table. Look at that table that I showed you. Bromine is in group 7. So it will be minus what? -1. Please take note of that. Let's look at another question quickly. I don't want to go beyond time. Question 9. Electrons that are free to move in a metal are referred to as okay. So let's make this a previous knowledge then. Okay. So delocalized electron. Delocalized means that it is not localized. Okay, it means that it is free to move about. So please note that delocalized means it cannot move what? About. It is mobile. Okay, so last one is question 6. What charge does potassium ion have? What charge does potassium ion have? Potassium is a metal, +1. Remember the 3 questions we asked. Okay, how many electrons will I lose? Who will lose electron? And is there a clue? Okay, so potassium is a metal, and metal, okay, metals lose electron. Potassium is in group 1, so potassium will lose one electron. Okay, brilliant work. Okay, the person that came first, you are going to be getting, except for this is coronavirus, I need to ask from you, you are going to be getting pizza delivered to your house. Okay, yeah. So if you can accept a delivery van or whatever because of corona, but if you can't, okay, it's fine. It will go to person in number 2, okay? Or we'll keep your price here another time. That corona is over, then you get it. And I'm being very serious, please, okay? So thank you, everyone. This is 6 o'clock. I want Coach Adeyemi to address you, please. Coach Adeyemi. Coach Adeyemi.
Right, thank you everyone for joining.
Yes.
I want to believe that you have had a great section with Mr. Lanre Ogutoye today. And we are really, this is not going to be the end. This is just a taster. We want to know, and we also want to get feedback from you, please. Post your feedback in the chat section.
Yes.
What is your assessment of this class? Did you enjoy it? Were you able to learn something via this medium? Please post that in the chat section. And then the WAEC preparation for chemistry practical is something very close to our heart. I want you all to participate. Thank you very much. Have a wonderful evening.
Okay. Thank you, Coach Adeyemi. Please appreciate Coach Adeyemi. He's one of the brain box behind this the success of this program. Okay. So please post your comments, your feedback in the chat section there. Just post it now in the chat section. How you enjoy this class, whether it's enjoyable, whether you want more of these, post it in the chat section. You can do that now. Okay. Our time is fast spent. We do not intend to keep you beyond this time. Okay. Thank you, everyone. Or if you want to speak orally, it's fine. You can speak orally if that is what you prefer. You can speak orally. Okay, you can speak orally. Good. And I need to get to know a few of you that are meeting for the first time. Okay. Yeah. Is there any other teacher here apart from Mr. Neke, Mr. Temitope, any other teacher? Okay. Yeah. Okay. Thank you. Thank you. Yeah. Okay. Yes. You can also suggest what we can do to make it better. You can suggest. what we can do to make it better. You can suggest what we can do to make it better. Yes. Yeah, Simi-Sola. Okay. Yeah. Fantastic responses. You had brilliant responses and your engagement was fantastic. Yes, Usondu, you engaged the class. Let me to give you feedback. You engaged the class very well. Simi-Sola, you were just mind-blowing. Angela was extremely fantastic. Okay. Yeah, Angela is in year 9 and she did amazingly well. And I think she did amazingly well. Yes, Tahira, yes, well done. Oyewo, yes, Oyewo Tulu. You couldn't participate in the quiz, but maybe you joined late. Just say you joined the quiz late too, but well done, well done, well done, well done, well done, well done, well done. Fatima from Kano. Okay, that's a long way. Okay, I appreciate your thirst for knowledge and your quest for knowledge, Fatima. That's a long way from Kano. You can see that there is no barrier to loss. Abisola, brilliant, brilliant. Thank you for your participation in class. And Olatubo Tomi too. You actually used the chat room very well. You did so well. Well done, everyone. Well done, well done, well done. If I didn't call you, it's not. Yes, Mayoko. Yes, Mayoko and Oluwamumiyo. Yes, Oluwamumiyo. I can still scroll back to the chat room. All your responses, you are just, when you say something is just correct. Yeah, well done, well done.
Simi-Sola is giving us a suggestion.
Yes, sir.
Simi-Sola is
yeah, okay.
Simi-Sola 603.
Oh, 603.
Yes.
Okay, 603. I'm trying to scroll to that. Okay, we could probably have more group discussion. Okay, yeah, okay. Thank you. Brilliant. Thank you. Next time.
Also Tyra Barazik before Simi-Sola.
Okay, we could have. Yes, we could have videos. Actually, I have videos, but I was trying to play it and I noticed it was hanging, so I had to let it be. You know how PowerPoint behaves. It could just hang now and it would destroy all the work. So I just let it rest, JJ. Okay? So I will look for a better medium that will not, that will be technologically favorable for us to play videos. Okay? So I noted that videos and group discussion. Okay, that's very
actually cool. But for the whole section, we have the recording on YouTube. We were on YouTube live.
Okay. Oh, so brilliant.
We are going to drop the YouTube link for everybody to get.
Yeah. Also, the notes for this class, the PowerPoint explanation, I'm going to be sending it to the emails of everyone who registered.
Yeah, exactly.
So if you didn't register, maybe you can actually drop your email here now so that you can get to it. Some people register, some didn't register. Okay, so the essence is that you can get materials and information. Okay, yeah. Thank you, everyone. My name is Larry Ogutoye. I'm the inspirational. Okay, I have a very deep love for chemistry, and I appreciate elegant, beautiful, delectable, intelligent, Aneke, and a fantastic teacher, Mr. Akinusi. You need to meet this man, Mr. Akinusi, everyone. You need to meet him and hear him teach chemistry, okay? You will feel the energy and the vibe that comes from that, okay? Yeah, thank you, everyone. Thank you, everyone. Thank you, everyone. I appreciate you coming out to hear from me. Yeah, thank you. So, yeah, if you don't have much time to stay, you can just, the class is over, so you may want to do something else, okay? But if you want to hang around to chat for like 5 minutes, you are free to do so, okay? I appreciate every one of you. Thank you for joining us, okay? So we look for more and more sessions like this. Good. Chemistry is a very simple subject. It's lovely. Let no fear of chemistry be in your heart, okay? In fact, I actually had issues with chemistry. Maybe I didn't tell you my story. My SS1 and SS2, they were horrible days for me because of chemistry. I don't just know why all these atoms and molecules and ions, they were not just making sense. Even though I was a brilliant student, I was doing well in math and every other subject, but just chemistry was horrible. But because of my love for arts, okay, I like to draw and do artwork. So one day I decided to sit down, I took my chemistry notes and I was painting every single equation there. And apparently over time, I find myself always being with my chemistry notes. And in fact, I actually started with organic chemistry. And I can tell you all through my university days, on campus, they know me. When it comes to tutorial of organic chemistry, I take every other student, undergraduate student, tutorials on organic chemistry. But when I look back, it wasn't like that. But I found a passion that I used to connect to my love for chemistry. You can also do the same. You may not have been doing so well in chemistry before now, but look for something that you love related to chemistry. Chemistry is life. Chemistry is diversity. Chemistry is colorful. Chemistry is brilliant. And chemistry is simple. Okay? Yes. Thank you, everyone. Have a nice time. Okay? Good, good. A student from Methodist Girls College. I think I have a lot of you here. Yeah, thank you for coming. Send me word to your friends, to your teachers. Next time, make sure you join. When you get a link, send it to all your friends. Methodist Girls College. And I forgot one other school mentioned though. So yeah, student from Green Spring School, you're fantastic. Thank you for joining. Okay. Abisola, you're still online, right? So I forgot your school. You can also drop your school. Yes, just type the name of your school in the chat section. Just drop it. This is the school you came from. Drop it there, and we'll be fine and good to go. Okay. I appreciate everyone. I appreciate you so much. Okay.